We have seen the protocol stack used in classic Internet with the most widespread protocols. Today we will look at its evolution to integrate connected objects that are memory constrained and energy autonomous. Regarding Level 2, the goal is to save energy during transmissions. We can already say goodbye to Ethernet as it would require using wired infrastructure, and thus we couldn't place objects where we want, especially if they move. Radio wave communications are preferred. For the Internet of Things, Wi-Fi is also too energy hungry. It is therefore preferred to use an evolution called IEEE 802.15.4, which takes its operating principle but adapts it to low throughput and small frame sizes. In particular, to save energy, the range is reduced to about 10 meters and relays generally need to be used to reach a destination. Bluetooth has been adapted for low consumption objects with BLA, Bluetooth Low Energy. On the cellular phone side, protocols are evolving to take objects into account. The 4G standard has integrated lower throughput communication. 5G will include a class allowing communications with energy efficient objects and reducing latency times. Finally, a new class of networks has emerged with LPWAN networks. They are dedicated to objects. LPWAN means Low Power Wide Area Network. They allow transmission at low power over long distances, 2 kilometers in cities and 20 kilometers in rural areas. However, traffic is heavily constrained. The two most well-known representatives are Sigfox and LoRaWAN. We will see in more detail how to use them, and if you are lucky enough to have a PICOM, you can experiment on these networks. At Level 3, we are moving towards using IPv6 since version 4 has its address space saturated. But IPv6 involves larger headers, which is problematic because Level 2 networks carry smaller frames. Therefore, we have two adaptation sublayers that will compress headers. 6LoWPAN for IEEE 802.15.4 type networks and SVHC, or CHIC, for LPWAN networks. Above we saw that, as HTTP was dominant, TCP was too. But for IoT, this is not optimal. Indeed, TCP and HTTP are complex protocols that require a lot of memory. To reduce the impact of the protocol stack, IETF defined a new protocol called CoAP that requires only a few kilobytes to operate. CoAP relies on UDP, which further simplifies implementation. CoAP allows manipulation of resources identified by their URI, thus fits seamlessly into the web architecture. For data structuring, XML is not used because it is too verbose. JSON is much more efficient for transporting structured information. There exists a binary equivalent that we will see later called CBOR, which is much more performant, simple to implement, and compatible with JSON. Finally, the beauty of the Internet protocol stack is that you don't have to implement everything. For example, the Linky electric meter that all French people know only implements a part of it. Instead of using CoAP, electricians use their own applications following the DLMS COSM standard. This relies on UDP, then IPv6 and 6LoWPAN, and finally on a variant of IEEE 802.15.4 adapted to carry information over power line.